Today we'll be taking a closer look at the basics of the physics engine, a program which applies the laws of physics to virtual objects. As our planet becomes increasingly digitized, the need for virtual physics becomes more and more important. From early video games to multi-million-dollar movies, physics engines have become increasingly more advanced and refined, up until the point where they are almost completely realistic. The physics engine incorporates lots of laws from traditional physics, such as kinematics and air resistance, and applies them to virtual objects. We'll take a closer look at a few of the most important aspects of the physics engine. The first of these is a rigid body. A rigid body tells the physics engine to enable physical behavior for an object so that it can act and be acted upon by different digital objects. Another important tool is collider components, which define the shape of an object for the purposes of physical collisions. A collider is an invisible field that surrounds an object and shows it how to interact with its environment. But all of this would be completely unrealistic without a way to tell objects what material they are made of. This is where physics materials come in. When colliders interact, their surfaces need to simulate the properties of the material that they are supposed to represent. For example, a sheet of ice will be slippery, while a rubber ball will offer a lot of friction and be very bouncy. When you combine all these things, you create a framework that allows digital objects to act according to real-world physics.
That's it for this week's Computer Chronicles. We'll be back here again next week with another half hour of the latest in personal computer technology. I'm Stuart Chaffee. See you here next time.
Computer Chronicles is made possible in part by Hewlett-Packard Personal Computers, developing PCs for business. Videotape copies of all Computer Chronicle shows are available for $32.50. Please order by show number and topic.